into the reasons why, but to put it very simply, anything I do in class, I want to be accessible for you all outside of class. That means every PowerPoint, any problem I solve, anything that I work through, you're going to notice I do all my problems on the computer versus the whiteboard, because the whiteboard gets erased, whereas anything I do in the computer, I save the document, I upload it to you all later, so any problem solving I do is also available. We'll get into the streaming. That means, regarding the streaming, to put it very simply, you can be in class, you can be at home, that's fine. I will prioritize you all that are in class. So I do the streaming thing to make it accessible and all that jazz, but I can't promise that technology will always work. If internet's out and stuff like that, it happens. I have taught in this course one time before, last year in the spring, so same old, same time, different room. I had one day out of the entire semester where the internet was real funky and I was floundering around and I got it maybe figured out halfway through. Otherwise it should work, but no promises. The delay on it, there will be a slight delay, nothing too big, but it should be largely possible for you all to engage a side class. Just if it doesn't work, it doesn't work. So there's that. Alright, so we'll get into who I am, we'll get into what the course is, that's the main point of today, we'll get into some of the content. So here's me. Dr. Wesley James, Dr. Part, whatever, all that does is it lets me teach. That's as far as that matters to me. You can call me Mr. James, you can call me Dr. James, you can call me Prof, you can call me teacher, you can call me Mr. J. I'm going to insist that I am an adjunct instructor. I teach high school during the day. I teach high school physics, honors and standard, and that's the Lake Mary part of me. My students call me Mr. Dr. James. I don't care. You can pick your poison. So, that's me. You can tell because it looks like me. Woohoo. That's my wife, Holly. That's my daughter, Kinsey. She's almost 2 years old. She's stinking adorable. Love her with all my heart. I got my PhD at UCF. I got my master's here at UCF. I got my undergrad here at UCF. I was born and raised in Florida. Been around here the whole time. I've had a class in this room. I could not tell you which one it was, but I have been in this room before. It's somewhere in this seats. My PhD, my master's, my undergrad, all physics, though my PhD was specifically researching how to better teach physics. So my PhD, very long thing that I will never read or look at again, was how to better design college physics courses to better support students with disabilities and ultimately all students. Universal Design for Learning was the key emphasis of it. Feel free to try to find it. It's in the UCF network. It's fine. The PhD is fine. Again, it lets me teach. That's what I care about. So, great. UCF. I teach high school. That's what I've been doing for the past 3 years. This is my 4th year teaching high school now. And then I adjunct on the side because kids cost money. So, that's how it goes. So during the day, high school teacher, and then I come straight over here. And the last piece of me that's important is I'm a Christian. This is the one and only time you're going to hear me talk about this, and I am telling you all this because the reason I'm a teacher is I care about people, and why I do that is because I'm a Christian. So I care about every single one of you. You are a human being, and therefore you have inherent value and worth, and I believe that regardless of any aspect, any other part of you, whatever you may believe about yourself, what others may believe about you, I care about you as a human being. You have inherent value and worth because of that, and I want you all to know that, and I want you to know that I believe that. And to that end, there's that. And I also want to mention it is possible to both believe in science and also have faith in things outside of that. So, things, supernatural, stuff like that. That is the only time you will hear me talk about my faith. I'm here to teach, not preach, but it's an important part of who I am, so I put it up here. There you go. All right, so we're going to go over the syllabus. We're going to go over the course. That's kind of the main emphasis today, to tell you what the course is going to look like, how to be successful in it, what assignments are going to be done, the weightings, all the logistic stuff that happens the first day. And then, we'll get into some content because we got an hour and 20 minutes, and I'll make sure to use every minute of it because you're paying me. So, jumping over to the syllabus. Well, actually, let me quickly jump to the web courses, because web courses is where you're going to find everything, including the syllabus. On the home page, it's in giant font. There's a link to it right there, so at any point, anything that you're curious about will be right there. Again, anything I show you in class, there will be a link to it on here. So, as things kind of come up, for example, the PowerPoint, you know what? I'll just show you that right now since we're going to be going through the PowerPoint. Every single PowerPoint is already uploaded on here. So there you go, week 1, that's what we're on right now. There's a PDF, there's a PowerPoint version of it. Every single week is there. Just thank goodness I've taught the course before, so I've made everything. And it's all good to go. As the classes go on, so after today's class, if I actually end up writing on the PowerPoint, which I probably will, I will upload that immediately after class to this same place. So anytime I work on a PowerPoint, I'll upload a new version. All the old versions will be there, but it'll have the date for the latest one and all that jazz. You'll see as I do that, it'll be more clear. So over to the syllabus. Bam, talks about me, already done that. Bam, you're in class, you're in the right time and place. Fantastic. Office hours. These are in PSB 146, Physical Sciences Building. They are from, I'll show you where that is on the map in just a little bit. They are on Tuesdays and Thursdays from 3:30 to 4:15. So literally right before class, I go straight from high school, straight to there. Every now and then I'll get there. So I will get to that room between 3:15 and 3:30. So sometimes it'll be a little bit early, sometimes it'll be right at 3:30. Depends on traffic really, because I just head straight there. I will be in that room on Monday and Wednesday as well. I teach a different class Monday, Wednesday, Friday, similar times. So I teach Physics 1 on Monday, Wednesday, Friday. My office hours for that class are Monday, Wednesday. You are welcome to show up to those. Just know I'll prioritize Physics 1 during that time. If you're in the room, I'll still work with you. I generally do not have so many students that I can't work with everyone. But if I do have a bunch of people, I'll prioritize them during Monday, Wednesday, and I'll prioritize you on Tuesday, Thursday. I've already told them that as well. But that's an option. So just know that Monday through Thursday, I'm in that room. Physical Sciences Building. You may or may not know where it's at. I only knew where it was at once I became a physics major and started going to the physics department for various things. So here's UCF in all its circular glory. So here's the Mathematical Sciences Building. We are, depending on where you're sitting, somewhere in this area. As I mentioned, UCF's all about circles, pathways galore. So this outer circle, so when you exit the building, you kind of walk this outer circle. If you just go counterclockwise, not too far, you'll run into the Physical Sciences Building. There's a parking lot there that'll indicate that you're there. The water tower is right over here as well, so it'll be kind of across from it. Big rectangular buildings, 4 stories. It is mostly labs and professors' offices, and it's where I'll be teaching, where I'll be doing my office hours. PSB 146 is the first floor, and it's that first corner you run into. You can either enter through the side of the building or the front of the building, but you'll head to this corner. I'll be there. You'll see me. There's a little room there. I'll be in there, chairs and whatnot. Loved for y'all to come and visit me there. So as I mentioned, I teach high school physics. One of the beauties of high school physics is only having 20 students in the class where I get to know every single student, their name, bits and pieces about them, all that jazz. There's 100 of you all. I can guarantee I will not learn all your names. I will get to know the people that come and talk to me either before class, after class, office hours, stuff like that. Otherwise, 100 people. I have 110 high school students total, so you all almost are as many as my entire high school course load. That's just the difference between a big university and high school. That's how it goes. But yeah, love to get to know you. Come meet me. I'll be there. I'll be here. At any point, if you have questions before class, after class, so I leave office hours at like 4:15. I'll come over here, usually be here about 10 minutes before class, getting everything ready, but come up, ask me questions then. I will stay after class as long as necessary to answer any questions that you all have as well, including today. So lots of options to ask me things. In general, you want to be working with someone in this class. You are totally, if you want to go solo in this class, go for it. But one of the best recommendations I can give for you all, if you're struggling, is either to work with another student, work with me, work with a tutor. I haven't heard anything from SARC or anything like that, but once I start hearing, usually they contact me at some point in the first couple weeks. Hopefully they'll come and talk to you all. We'll see how that pans out. If not, I'll start looking into it if I don't hear from them. There's lots of people you can work with, both in this room and outside this room, to be successful in this course. All right, so office hours, description of course, feel free to read that. The most important thing is you can be successful in here. Everything I'm trying to do for you all is to help you with that. So working together. Here's everything we're going to be covering, which I'm immediately going to jump down to probably the most important, the most useful thing on the syllabus. At the very end of the syllabus, the last page, is a schedule for the class, which has every single week what content we're going to be covering, and then also the exam dates. I need to update the final exam. When I made the syllabus as of last Friday, they didn't have those. I presume that if I search it up, even you may be able to search up the final exams at this point. So I'll add the final exam sometime in the next week. These 2 exams, the dates are locked in. The exams will be on those days. There's going to be 2 exams. We'll talk about what those are going to look like. But I just want you to know that I will not change those exams unless something crazy happens, COVID 2.0 or whatever. Otherwise, they're going to be then. You can plan around that. I want you to give you all as much heads up now as possible because I know people travel and all sorts of this, that, and the other. If you think there's any complications, feel free to email me now and we can try to work through it. If you have an excused absence or anything of such, what will happen is instead of, say, sick, doctor's note, all that jazz, or, the usual excused ones, family emergency, or if you have some kind of UCF event that you have the permission, what will happen is instead of taking on that day, you will hopefully be able to come to my office hours the next week. It'll be broken up into 2 pieces to make certain you get the same full amount of time that everyone did, and that's kind of how I navigate that. So, if needs be, you can make it up in my office hours a week, but that is only for excused ones. My office hours only holds 10 people. Obviously, I can't just do that for everyone, and plus it wouldn't be fair. So if you have an excused absence or whatever, let me know about that. All right, cool. So there's that. There's the days off. The only ones that really matter to us regarding days off are the spring break. That's factored into here. Next Monday, this following Monday, we have off, but I don't see you, so who cares? It doesn't affect you all or me regarding that. Cool. All right. So back up to the top. There's the course structure. That's what we're going to do. We're going to learn about electromagnetism. We'll get into that. Prereqs. If you're in the class, you've gotten those done. And I've already kind of gone over this part. Working together is key in any math, science-y kind of class, because the beautiful thing with these courses is there's only one right answer to problems, whether you like it or not. That's how it works. And to that end, if you're working with someone and you get 2 different answers, one of you is wrong or both of you is wrong. So it's an easy way to check your stuff. You cannot have 2 answers and one be right and one be wrong, so it's very handy for that way. In general, you'll find that I actually give you the answers to every problem that I want you to practice anyway, but we'll get to that. All right, so structure the class. What are you going to be doing? Lecture, that's where I stay. You all know what lecture is. No need to get into that. Most PowerPoints, clickers, stuff like that, we'll see that. Homework. Homework is a super trivial thing, which basically I put as an easy kind of grade booster thing and to fill in the weeks where we don't have quizzes. So there's 3 assignments. They're worth, I believe it was 70%. These are 7% of your grade. Not a ton, but enough that they're worth doing. Graded super easily. Again, I kind of put them to give something. There's a reason for it. It's not just busy work. So they're called Physics I Care About. They're very straightforward. There they are. You can see all the assignments right there. They will occur during or after the week of the exam. So this will be due the week after the exam, due to you'll pick any of the things we covered leading into exam 1, and you'll pick something in the world that actually uses that stuff, and then you use what you learned, use that thing, you'll explain how it works, you'll say, great, this stuff does apply to the real world. This can be as in-depth or this can be really interesting to you, or it can be busy work, depending on how you approach it. This can be a great opportunity for you all to basically take what we learned and see, oh, this applies to something that wasn't covered in class. That's really interesting. Now I know how headphones work. Now I know how electric sockets work. Now I know how my laptop works. The stuff that we were covering in this class is probably the most. You interact with the stuff we're going to cover in this class more than anything you covered in Physics 1. And we'll see why in a bit. It may not seem that way, electricity and magnetism, but trust me on that, it's everywhere. So very straightforward, very simple, not worth a ton of the grade, but it is important that you do it. You definitely don't want to lose the 7% just for missing it. All right, getting into more of the bulk of the class. Quizzes. The quizzes. Now, these quizzes, they have the word quiz, but basically they are my homeworks. I kind of put the word quizzes there because it's more accurate to the way they're assigned. So every single week, except for the week after exams, there is a quiz that consists of 5 problems. 5 problems. They are multiple choice problems. You will get 2 attempts on these quizzes. 2 attempts, I'll take the highest of the 2 grades. After you do an attempt, it will show you which questions are wrong and which questions are right. Each question does have multiple versions, so when you take it again, it is very likely that the problem that you get will be slightly different. One piece of the problem will be different. All right, so basically the same problem, very slightly different. These quizzes, even though it's 5 questions and it says it's graded out of 5 points here, you'll see in the syllabus that I actually grade these out of 4.5 points. That's something I have to do manually later on. Unfortunately, Web Courses, it didn't let me change the point value. So later on, I have to transfer these to be worth 4.5 points. Here's the reason why. It's 5 questions. You missed 1, that's an 80. That sucks. So by making it worth out of 4.5 points, there's twofold benefits. One, you can get over 100%. You get all 5 questions right, that's a 5 out of 4.5. That's over 100. That also translates to if you get 5 out of 5 one week and 4 out of 5 another week, those combine to give you 100%. That's how it works out mathematically. So basically, if you miss a question every 2 weeks, you still get 100%, which is really good. So that's one way of doing it. The lowest quiz grade is dropped. Basically, there's a lot of supports in place that I call these quizzes, but really they're kind of more akin to homeworks. Now, how do you prepare for these? This is the core of the class, something that is very important to me. So when doing my research in my PhD, I talked to a lot of students, and one of the most common concerns and complaints I heard regarding physics classes was not knowing how to prepare for the assessments, not knowing how to study for it, not knowing what to do, that the test didn't look like the homeworks, all that kind of jazz. And to that end, everything in this course is all aligned together, and vast majority of this class will center around something called these problem sets. So in the files tabs are these problem sets, and these are the key to your success as far as what to practice, what to prepare for, all that jazz. Each test, so test 1 goes with problem set 1. Test 2 goes with problem set 2, and problem set 3 will be what's left over after that. The final will be cumulative. We'll get to the final in a second, the test in a second. So when you open up one of these, there's a PDF and a Word version. I'll just open up my computer. You can see my organization on my computer looks very similar to the thing on here. So problem set 1, they have the answers. So I'm going to open the Word version, but there's a PDF version as well. Each week of content will have between 10 to 15 questions, usually not more than 13 to be honest, but I'm just say 15 in case one has 15. Each week is here, and it will have questions that I have specifically chosen. All of these are from OpenStax. That's the book that we're following. It's a free book because I don't want you all to spend money on anything. So I pulled these questions from there that cover the breadth of things that I will ask you to solve for. So all these questions are here. Every quiz question that I give you all, I looked at this problem set when choosing the quiz question. The quiz questions are basically modified versions of these problems. So basically if you've done this problem, there's a potential I have a quiz problem that will use the same technique. All you have to do is recognize that it's that same type of problem, and you're like, oh, I've done this one before. All right? The quiz problems will also pull from conceptual questions. Those will be the clicker questions. We'll get to those in a second. But as far as the math is concerned, if you can do the problem set problems, you should be good to go for my class. That's kind of the promise I'm trying to make to you all. If you can get through these problems, you know how to get the answer and all that jazz, you should do great on the quizzes, you should do great on the tests. I have yet to really have many concerns with that. If students aren't doing well in the class, usually the concern is I'm not sure how to do the problem set problems, like they run into a lot of problems with those. At which point I work with them and help them learn how to do it, or they haven't done the problem set problems. So, if you can do this, this is the technique. And the thing with these problem sets, they're not graded. This is do as much or as little as you want. At no point do I collect these, at no point are they graded. I mean, I give you the answers to every single one, because there's no point in practicing if you don't know the answer. So the answer is there, so that if you get to the final answer and it's not that, you did something wrong. The beautiful thing as well is that I've taught this class last spring, meaning they were my guinea pigs, meaning any typos that OpenStax had in their answers have been fixed. Even though I pulled these problems and the answers from OpenStax, they had some wrong answers. Those are no longer in here. Fingers crossed, unless somehow I didn't. They should be all fixed, because last year was my guinea pig class. All right, so they're all here. Some of these problems I will solve in class. Some of the trickier ones I will work on in class. Some of them I will point out in particular. For example, number 10. Is that the one that's terrible? Yes. Number 10 is one that I can straight up tell you There's going to be something similar to it, I believe, on this next quiz or future one. I'll double check that and get back to you Thursday. This is a hard problem. I specifically put it in here because this is the hardest type of problem you're going to have in this class. Like, this is as hard as it gets, this problem. So I specifically put it in the first week because it's better to start as hard as it gets and then kind of ease down than do the opposite. The first stuff we're covering in general is going to be tricky because of a wonderful word that I'm sure we all love with all our heart, vectors. Yeah, everyone remembers vectors, I'm sure. And if you don't, maybe that means you had a good experience or you blocked it out of your mind. Vectors traditionally are one of the trickier things for students. This one uses vectors. Also, it requires some setup. We have to be clever. I will give you all some hints about this one as the days go on. But I purposely put this one here. I purposely know it's difficult. Because it uses so many skills, and again, it kind of sets a tone. This is as bad as it gets. So it kind of sets a nice tone for that. It's nice to know where the ceiling is. At least that's my perspective on it. Maybe you'll hate it. We'll see. All right, so problem sets. Super, super key to the class. If you're not doing, at any point you're struggling, you come up to me, the first question I've asked is how the problem set's going. That's just how everything revolves around these. This is where you go to be successful. If you come to my office hours, that's pretty much what I work with students, is solving these kind of problems. All right? So there's that. Again, those aren't graded, but that's going to help you prepare for those quizzes. And then the quizzes are just kind of a way of checking, hey, how's that understanding going? Instead of me grading you on 12 problems, it's only 5. And I want to give you all the opportunity. The problem sets are there as well so that you do as much or as little as you want. All right. Tests. 2 midterms and a final. The grade breakdown is right here. So we talked about the homework. We'll get to the clicker questions in a bit. We talked about the quizzes. Midterms are going to be worth 30% of your grade, 15% for one, 15% for the other. The final will be worth 20%. Add that all up, that means 50% of the grade is exams. Now, exams suck, I know that. But it is unfortunately the only way, in-person exams, it's the only way to ensure that I'm assessing what you understand in a way that I can do for 100 students. The dream is that I do other things, but with 100 students, that's just kind of how it pans out. That's why so many classes use them. The other 50% of the class is kind of effort-based. You put in the effort, you put in the time. I expect you all to do great at these quizzes. Clicker questions for sure. We'll see how easy those are. That's freebie as well. Discussion sections, we'll get to that. That's freebie as well. 50% of the grade is basically you put in the effort, the time, you'll be fine. The test then is assessing, do you understand it? Ideally, if you put in the effort and the time, you'll understand it and it'll all line up great. Regarding the tests, some supports for you all, because I know that they're not fun. I know there's stress and anxiety and all those things surrounding it going into it. So there's a few things I try to do to reduce that. One is that the lowest test grade will be replaced by the final if the final exam grade is higher. So say you bomb test 1. If you do great on the final, which is cumulative, it'll replace that grade. So there's kind of that backup plan there. It's not fun maybe to have more stress on the final, but at least it's better than nothing. So that's one thing. The second thing is that you will be allowed to bring a 5x8 note card. I'll bring the 5x8 note cards. So as we get closer to the test, I'll have a stack of them. You'll come up and grab one. You can put whatever you want on the front and back of that card. I don't care. And that is in addition to the formula sheet I will give you on the exam. On the exam will be a formula sheet. The purpose of this is physics is not about memorization. So honestly, filling that thing with the tiniest go put whatever you want. Type it up. Type stuff up in the tiniest font in the world and put it on there. This is basically my way of, 1, reducing the stress, knowing that you kind of have this thing with you, and 2, tricking you into studying, because to make it, you kind of have to put time and energy into looking up the stuff. It's not like if you copy a problem, you're going to see that exact problem on the test anyway. But if there's a problem that you're really stressed about, sure, feel free to put that one on there. If you're like, man, this problem's really stressing me, what if that one shows up and one like it? Sure, put the solution to that one on there. Use it as a guide. It doesn't matter to me. I don't care if you all memorize it. I care if you all can recognize what type of problem it is, process through it, and solve it. Physics is not a memorization thing, so I have the luxury of doing this, unlike a lot of other classes. If it was memorization, I wouldn't be in it. My memory sucks. So, physics, no memorization. You just have to figure out how to solve them, make those connections. All right, clicker questions. These should be free points. I will ask a variety of clicker questions, 3 to 5 per class. No idea how many, it varies from class to class. But here's the takeaway for there's a few key points here. You get 75% of the credit for just answering the question. You get the other 25% for getting it right. But here's the good news. If I ask 100 questions in the whole semester, I will actually only grade it out of 75 points. What that means is that this 20.25 is basically just bonus points. Every question you get right in the clicker is just bonus points, meaning there is no penalty to answering these questions, as long as you answer all of them. Now, at the same time, I don't care. I want y'all to be successful. If you don't feel like you need to show up for class for that, then don't. If you want to show up for class for that, then do. At the end of the class, I'm not going to do this anytime sooner because I have to go through and manually do it. At the very end of the class, I will calculate the grade with clicker points and without clicker points. I'll take the higher of the two. So if you don't show up to a single class, meaning you miss out on the, 8% or something? I haven't memorized this up my 8% of points, then that won't affect your grade. Everything else will just be scaled up and worth a bit more than percentage-wise. Everything else will make up that 8%. So I'll calculate the grade with or without. We'll see what happens. And I'll take the higher of the two. All right. Regarding clicker questions, I sent out a thing about registering from. You can get a physical clicker. You can get a digital clicker. This is the only thing you have to buy in my class. The dream is that I wouldn't make you pay for anything, but this was just the only way for me to get some engagement with you all. It is useful during class for me to ask you all questions that you can respond to instead of me just spouting out stuff for an hour and 20 minutes. It's useful for us to pause, give you time to practice some of the concepts, things like that. So there's a lot of value in doing these. Remember the quiz questions, 1 or 2 questions from every quiz will actually be modified versions of these clicker questions. They won't be math-based. Any clicker question, if it is math-based, it's something you can do in 30 seconds to a minute. So these clicker questions are short, they're quick. If you've had them in class before, you'll know what I mean. But they're usually conceptual stuff. And to that end, the digital license will last you this semester. If you have any other classes that use it, you just buy it. It works for all of them. It's $15. If you have a physical clicker, every single version of the physical clicker should work. I will start to do clicker questions this Thursday, but they will not start to be graded until next Thursday. Okay, so I'm giving you all like a week and a half, which is a good amount of time to make sure you have a clicker together. I will post grades for clickers this Thursday and Tuesday, only so that you can tell if yours is working. After Tuesday, I will delete those grades. But I will post them just so you can make certain that yours is working with the class, because nothing would be more depressing than you using it all semester and then finding out it wasn't working. Or me 3 months in, updating the grade, 2 months in, updating the grades, you realize none of them were counting. So this Thursday, this Tuesday, I will be doing clicker questions. They will not count to your final grade, but I will post the grades just so you can see that, hey, is mine registering? Details for how to register, basically you just go to the link. If it's a digital one, physical one, there should also, I will have something I believe in WebCourse to link off to the side for how to register it there. All right, discussion section. This is the last piece of the class. This is the one thing that is largely outside of my control. Discussion sections exist for every single class. We have to kind of do similar stuff across all the classes, so I don't have as much flexibility here. So the problems you're going to see here were not necessarily chosen by me. This is the one piece of the class where the questions were not necessarily chosen by me. To that end, I do not look at the discussion questions when designing the test. I do not look at the discussion questions when designing quizzes. They're still useful practice, but just know that you're not, when you're studying, if you find them useful, go for it, but I don't necessarily look at those. All that to say, though, the grades here is fairly simple. 25% if you show up to it, 25% of that, this is worth 10% of the final grade. You get 25% of those points if you show up, 75% if you complete the assignment and turn it in on time. Fairly straightforward. If you all go to the discussion sections, what's going to happen is they're going to solve through those problems with you. That's the purpose of those. It's basically a problem-solving session with specific problems that every instructor is using. Okay? So they will not be the ones from the problem sets because other instructors aren't using the same problem set like that kind of structure that I am. All right? So I don't have much control over them. They exist. There's questions that we've all, when I say all, I started teaching last year. They're like, here's the questions. I'm like, okay, great. I guess I'm using these questions. That's how it went. This semester, I was like, all right, I guess we're using the same questions. Okay? So your TA will work with you. Again, the TA's job is just to help you solve those problems and make certain you get the right answers when you're in this session. So it's not just busy time or whatever. You are working on things. All right, Ray talked about the attendance. There's that. There's the grade structure. We talked about that. There's a financial aid assignment. Go ahead and make sure you all complete this. This is, I think, 1% of the homework grade, so it's not much, but it's something we gotta do. It's just a quick survey. How do you feel going into the class? How do you feel about your math skills? That kind of thing. It'll take you 5 seconds. But you all heard the spiel. Make certain you all do that so you get your financial assistance. And then the normal policies. Missing work. I mean, everything has time frames already built in. There's not, so excuse stuff. Give me an email. Cell phones, I don't care if you're on your cell phone. You all are not high schoolers, so I'm not worried about it. My high schoolers, oh my gosh, it's a pain. I definitely am on it with them. But you all, I don't care. You're paying for this. All right, academic dishonesty, don't cheat. There we go. Same thing. Consequences. Accessibility statement. I will talk about this because it's important to me. If you all either make use of student accessibility services for accommodations, or you're on the fence about it, or you're not even sure and you're like, is this a thing for me? Please make use of these. These are for any individual that identifies with any kind of disability, various supports and services, extra test time, all sorts of things, note-taking services. Please make use of these. I want you all to use these if you have access to them, or if you think you may have access to them, or you think you may want to get access to them, any of the above. Yes. Please make use of them. If you have any concerns, questions, comments about those, feel free to email me. But I want to fully support anyone that wants to, is using, or will be using those. Emergencies, same old, same old. I just got an email today that there's some button in this room where we can lock down the room. They get locked out. It's all the usual kind of stuff. Nothing too crazy there. Fire, we go leave the room. Active duty. Let me know as soon as possible so I can work with you around that. And today I reserve the right to make changes, always in there. But I will tell you, any changes I make will only be for your benefit. I'm never going to do something like moving a date sooner. I'm never going to do something like making something, I don't know what else I can do to make things worse. But nothing will get moved forward. Like any changes that do get made will be for your benefit. An example of that, so last semester, it's my first time teaching 2054. One of the things that happens when you teach a course is when you design the first exam, it's kind of I want to ask enough questions that if you miss, because they're multiple choice questions, enough questions that it covers the breadth of content, and also if you miss one, it doesn't hurt your grade too much, but not so many questions that you run out of time and can't think through the problems and stuff like that. It's a delicate balance as an instructor I have to reach. Because, for example, if I ask 10 multiple choice questions, that sucks. You missed one, you got a 90. You missed two, you got an 80. So finding that number, well, I overshot it last year. Had way too many. People did not have time to finish those. As we get closer to the exam, I'll talk about this more. I believe, and I'm going to 70 or 80% of the grade on the test will be free response or multiple choice questions. Easy for me to grade. I can ask a lot of them within reason. 20 to 30% of the grade will be free response. I will give you 2 problems is what I landed on. You will pick one of them to solve. So, as we get closer, I'll talk about that more. Well, I gave way too many. I gave 3 free response, I had people solve 2 instead of 1. And then I had too many multiple choice, and the result was, it was messy. Ideally, after the exam, at least 50% of you finish before time is up. That's a sign to me that I gave enough time. If you take the full time, that's awesome, no problem. But in general, I do not want everyone if everyone's working to the end, that's a concern that I had too many questions. And that was the reality. I had too many questions. So the result of that was that the second exam had less questions, and I implemented the policy, and I changed how I graded it. And then the final exam, I implemented that can replace test 1 as well. So to that end, that's an example. Now that I've taught it, in fact, I will actually post, it's sometime this week or something, I will post last year's exams for you all with not the worked out solutions, because I don't have those, but I will have the answers. So I will have what test 1 looks like. Before I post that, I'll warn you that it's longer than the reality is going to be. Test 2 will be the one that you're like, this is the length of an exam I expect to have. That one worked great. And the final exam also worked great. So those will be kind of as far as that. I will put all the questions I had in exam 1, because extra practice is extra practice. Do it or don't. But just know that exam 1 will not be indicative of the length of it. But I will post those with the answers, because I'm not going to use the same exact questions. You're a new class. I know how things work. Things get shared. Make sure it's all equitable, that no one gets an advantage from knowing people from last year. But those will get posted at some point, and I'll talk about them then. All right. So all that to say, any changes will be for your benefit. All right. As far as I'm aware, I have gone through all the things in the syllabus. There's usually one or two things I forget about, and I'll mention next class when I remember them. It's a lot of information. Is there any questions about any of that, about the course? There's no stupid questions here. It's a lot of information about it. All right. After a couple weeks, we'll start to get into a rhythm of it. It's like every course. You figure out what the course is like. You figure out what you need to be successful. Every single course is different. Please email me at any point if you all have questions. I can almost promise, again, pending no emergencies, that if you send me an email, I will respond within 24 hours, with the exception of weekends. Work-life balance is important to me. I can promise you I will not check my email. I will promise you that I am not intentionally checking my emails on the weekend. Maybe I'll be on my computer like, I'll just check it real quick. Every now and then I respond to one on the weekend. In general, though, throughout the week is when I respond. So pro tip, if the quizzes... let me mention this about the quizzes. So we're covering the first week of content. See, there's just all these things that so many details that some of them pop up as they pop up. We're going to finish the first weeks of content during the first week, this week. The quiz will open on, I have to double check, Thursday or Friday. The reason that, there's no reason for me to have a quiz open if I haven't taught you everything for the quiz. The quiz will then open, and you will have all the way till Saturday at midnight to take it, a week and a day or so. So you have plenty of time to engage with it. But there's a reason I don't open it early, because I don't want people to accidentally start it before they're ready, stuff like that. And to that end, if you wait till this Saturday to ask me a question about the quiz, I will not see it. You have about a 90% chance of me not seeing it. And regarding the quiz in general, so after we finish, ideally you start going through the problem sets, maybe by Wednesday-ish, you're feeling pretty decent. You try the first quiz, you say, I missed one or two problems, let me brush up on those. You learn, and then you take the second attempt, one of these last 3 days. That's the strategy I recommend for you all. Start working on the problem sets sooner than later. Make certain you take the first quiz attempt not on the last day, because you want to give yourself time to learn from any mistakes you made. I give you 2 attempts so that you can actually learn from whatever problems you got wrong. That's the goal. That's why there's 2 attempts. Again, these are effectively my homeworks in that way. So, there you go. Pro tip. Okay. So there you go. Emails, all that jazz. Any questions before I start to get into some of the mathy stuff now, the actual content?
Is this where we do the clicker?
Beliefs, yes. If you have a physical one, yes. Yes, if you have a physical one, that was the iClicker tab off to the side on web courses. Yeah. If you have a physical iClicker, there's a tab on web courses that says iClicker. You'll register it there. If you have a digital clicker, aka the app or whatever, there's a link I sent out in the announcement. So let me quickly show that announcement. Boop. There's that iClicker tab. It's going to look different for you than for me. Any important, I've already said, hey, welcome to class. That was the first one. And the second one I sent today, it's a link to my YouTube stream. So if you do want to stream the class, it's there. And when I say the class is streamed, one of the reasons I stream it is it's automatically uploaded to YouTube after that. So you can also view it after the fact if there's anything you want to. If you just love the sound of my voice, go for it. There's a link to the digital iClickers to register as well. So digital ones are there, physical ones are over here. And again, we'll have a week or so to kind of get that sorted. But do it sooner than, try to do it by Tuesday so you can make certain it connects. Because Thursday, they'll start being a part of the grade. Not a huge part again, we kind of went over that. But, alright, cool. Getting into stuff. Here is the things that you all need to have kind of in your back pocket to be successful. It's a lot, math skills. The same skills you needed for Physics 1, shock and awe, you need for Physics 2. You need to be able to rearrange problems to solve for variables, algebra skills. We're going to get a lot of practice with that. Trigonometry skills, aka vectors. Being able to take a vector and break it into its x and y component. That applied in Physics 1, it's going to apply in Physics 2. We live in a 3-dimensional world. We're going to be talking about forces in this class as well, but forces due to electricity and magnetism, and therefore forces are vector. We have to work with them. We don't have vectors because we want to make your life harder. We have vectors because that's how the world works. Anything I'm teaching you all in this class is just because this is how the world works. We don't get to decide how the world works. We just get to explain how the world works. And math is the language that we use to understand this world. I like to describe math as the language of logic. So just like English is what we use to express complex ideas, math is used to express complex logic, cause and effect. If this, then this. If I have 2 things and 3 things and I add them together, I have 5 things. That's what math lets us do. In fact, I have this blank slide. These are good for me. These blank slides are because this is somewhere, so as you're going through these projects, like, why does he have a blank slide here? That's because last year when I taught it, I needed extra space to write. Look, I need extra space to write right now. Oh, what a nice blank slide for me. So, let's just quickly remind ourselves about vectors because it's worth the 5 seconds it's going to take. So we have a hypothetical thing, just to remind you all what this has been like. Who knows when you took it last? Some force. Who cares what it is? If I want to break that into its x and y component, I make a sweet triangle. This angle, some angle will need to be given. We will need this part will be its y component, this part will be its x component. It's a triangle. SOHCAHTOA. If I have this angle and I have this is the hypotenuse, this is the opposite side, this is the adjacent side. If I want to solve for the opposite side, I am going to use sine of theta equals opposite over hypotenuse. Plugging in the things. Again, this is just a general refresher. We're going to get lots of practice. Trust me, we'll do ones with the stuff we're doing in this class. F goes there. Fy in this problem equals f sine theta. All right, and then you repeat that for cosine of theta equals adjacent over hypotenuse. I will not go this quickly when I'm solving new content with you all. I'm going this quickly because I assume you all, this is just, hey, here's vectors, reminder, here it is. When I'm solving problems, I'm going to go a lot slower so you actually have time to write. This is just, hey, here's what it looks like. Hopefully jogs your brain and like, oh, that stuff. I loved it so much with all my heart. All right, fx equals cosine theta. All right. There's that. The reason we need to do that, we're going to see when we get through stuff today. All right? So we'll have some problems today, or if not today, Thursday, where that's going to come into play. All right? So it is important. It is necessary. An easy example of why we have to do components is if I push a box this way and I push a box this way, I don't just add the numbers. That's just not how the world works. If I push a box to the right and I push a box up, I combine those and ta-da, the third side is the third side of a triangle. You'd have to do the other piece of the pie here. Let's call this x, let's call this y. If I wanted to solve for this, which is the total, Pythagorean's theorem, x squared plus y squared. So that's just how it works out, y'all. I don't make the rules, I just teach them. There will be something just given. So this is why the first test we have is going to be the hardest, because it's going to have vectors on it. The second test will not, or at least not as many. It'll kind of have some, but the first test is where you're going to have to use some more of these skills. And just, I know these are notoriously difficult for a lot of students. So if you do great on the first test, it only gets better from there, generally. Everyone's different. And I put this here on web courses. I provided a document. So if you're like, ooh, he just did a bunch of stuff, I don't remember any of that. I have put just a small little document here. It's nothing fancy, but it basically has links to a bunch of Khan Academy things. If your trig skills aren't great, bam, there's 2 links for practice problems, vector problems, free body diagrams, conservation of energy, and then there's that whole unit conversion. We'll do plenty of practice with that. But this is there. If you are stressed and it's like, oh crap, there's some things here I want to provide for you all. Feel free to use them or don't. The choice is yours, but they're there for you. All right, so as I mentioned, vectors have a magnitude and a direction. Scalars are just a magnitude. That's going to come into play. Scalars are much easier to work with because you don't have to do any of that trigonometry stuff. Vectors, you do. Units and variables, you need to remember some of the simple units. For example, time is measured in seconds. Distance is measured in meters. Whenever you're using the equations, all the equations we use in this class are calibrated for the base units. Meaning, if you're solving for something and you use kilometers instead of meters, your final answer won't be correct. So we're going to be practicing, making certain we can do that. That's going to just come into play naturally. You'll get rounded, you'll get polished up in those skills real quick. So that's very straightforward. Just reminders of the things that you learned before that are going to come into play. Don't forget your unit. Oh, wow, it's broken. Great. It's working here, not here. All right, how are the rest of my pictures? Fingers crossed. Some of them aren't there. Awesome. All right, well, we're going to see how that plays out today. Needs be, we'll just, let's see. This is going to be so jank. Nope. Now they're all broken. All right, who knows what happened with them? Oh, look, all my pictures are gone too. All right. Let's just close it and reopen it. Sometimes the magic of, have you tried restarting it? Works. If not, I will have the pleasure of re-uploading a bunch of pictures. As I told you all, technology is promised to know when to work. All right. Am I beautiful again? I am. Great. All right. Is everything? Oh, so good. All right. So don't forget your units. So this, unfortunately, I know this is going to happen to me. I don't know if it's my computer or what. This computer is a workhorse. This thing got me through my dissertation, and it's been used for a lot of high school. But every now and then, the PowerPoint in particular has some quirks. So, as I mentioned, I'm going to be drawing on the screen from time to time. There's a bug on my thing where every now and then that drawing will persist across things. So just be prepared that could happen, and then I have to close it and open. It's great. So fun. I love it. Anyway, units. Don't forget your units. So I'm teaching also Physics 1, and one of the questions I asked them is, what is 3? It is an idea. 3 what? If I told you I'd pay you 3 to mow my lawn, 3 what? 3 cats, $3, 3 gold bars, 3 blades of grass. A number means nothing until you put a unit after it. That's what distinguishes physics and math, is our stuff means something. Math is useful, obviously we use it, so don't hear me saying math is crap. But units are what makes our numbers actually mean something, so don't forget them. Now, you all have the pleasure. My high school students, because I only have 20 of them, I can grade a lot more of their stuff that's free response, and so I knock off points when they don't forget their units. You all are kind of blessed in that it's multiple choice, so the units are kind of already built in there. Free response won't be the case, but that's only a tiny piece of it. But there will every now and then be a problem where there'll be 2 answers that are the same number with different units. So do be careful when you are answering problems to make certain that you're picking the right units, because units do matter. Here's the conversions. We're going to see this a lot. There's only a few. So metric unit is best unit. You just move the decimal place. It's awesome. So obviously we're going to use the base unit. Kilo may come up. We're going to be working with a lot of small stuff in this class. Physics 1, you may have seen kilo a good amount. In this class, we're going to be working with meters. We'll see centimeters. We'll see millimeters. We'll see micrometers. We'll see nanometers. We are working with small things in this class. We'll see why very soon. And as we do so, we're going to need to remember to put these scientific notations after it and convert our units. If I give you 10 centimeters, you will not plug 10 into the problem. You'll plug 10 times 10 to the minus 2. If I give you 5 millimeters, 5 times 10 to the minus 3. Now, regarding notation, I use this notation almost exclusively. Instead of times 10, I use a capital E. Why do I do that? Because that's the button you hit in your calculator. When you plug in your calculator, that's what it looks like there. Also, it's shorter than that. And it's easier for me also to put in PowerPoints and all that jazz. It's just better all around, in my opinion. So whenever you see me doing scientific notation, you're going to see that capital E instead of a times 10. The first few times I'll put both just so we can get used to seeing it. But this is my preferred notation. It's what your calculator looks like. And the cool thing then is when you're writing out the problem on your paper, if you put the E instead, when you plug in your calculator, it'll look exactly the same. So it's easier to also make certain that what you're plugging in is what your calculator. Now, some of your calculators do the times 10, but a lot of them use that capital E, at least the ones I've experienced. All right, bam, what are we covering? What's the actual course content? This is really the center of the course content, positive and negative charges. How they interact with each other. That, if I had to say in a nutshell, like one sentence, that's probably what I'd say. I mean, other than electromagnetism, all that jazz. Positive and negative charges. Everything in the universe is made up of positive and negative charges. You are made of positive and negative charges. This table is. Everything is. When I told you that you all interact with this more than anything else in the universe, easy example, it's the reason my finger doesn't go through this table. We're going to learn about that in this class. Obviously, electricity is very important. Every single thing in this room that uses electricity, we're going to have some better understanding of how that works. What is electricity? We're going to learn what that is. Magnetism we'll learn about as well. That is also more in play than you realize. Your headphones. Magnetism is involved there. Often we just think of magnets as something that sticks to something. Is this magnetic? Yeah. Nope, not even magnetic. All right. This is, that isn't. Magnetic, you're played with the child's magnets and all stuff like that, but it is actually way more in play than you realize. It's how we generate electricity. There's magnetism involved in that. Any electric motor, there's magnetism involved in that. Anytime we're transforming electricity from higher voltage to lower voltage, that's less common, but very important still. Anyway, super, super common. So, even though you don't see it, and for you all, it is also very, if you're a health science major, that's generally most of the people in this room. I know there's a bunch of majors, but I know usually health-related stuff. This is going to relate to how all the ions in your body, well, how do cells, so I won't get into too much details because I don't know them, but I know the basics that cells, how do they actually get the minerals and the ions and whatnot they need? It's based on the mechanisms we're going to talk about. It's all based on these principles. Gravity, so there's 4 fundamental forces in the universe. Gravity, electricity, and magnetism is the second. That's what we're going to talk about. Third one is the strong force. That's the one that holds protons together in the nucleus. And the fourth one is the weak force. It's responsible for radiation. What I just told you about the last two is about the extent of my knowledge of them. The electromagnetic force is way more common than gravity. Obviously, gravity is pulling you down. But we're going to see how much electricity and magnetism, way more common, way more valuable. All right. So every single week, I will kind of have one of these. It has both the chapter and the OpenStax textbook. If you choose to use that, feel free. You don't have to. And it's going to have what we're going to cover during the week. So just a quick overview. So we're going to talk about the model for electrical properties and materials. So what is this thing of charge? How do you move charge from one object to another? What ends up happening? How can we describe the forces between them? What is this force? All that jazz. And then what's an electric field? All right, so we're going to use all your math skills you all talked about before. We're going to use some concepts you all talked about before. But a key thing in physics is starting from observations. Observations of reality. And then we say, why does it do that? And we build from there. Physics is all about a baseline, going as simple as we can. We observe an apple falling. We say, why does it fall? There must be something happening between those. What is that? And you go from there. That's where I make the statement, we don't get to decide how the world works, we just get to explain it. That's where physics comes into play. That's all physics is doing, is trying to understand this big wide world we live in. Feel free to watch that video, I'm not going to spend time on it. All right, so charge, I'm sure you remember this. If you don't, high school chemistry, the plum pudding model, it's like one of those things. So, slight history here of the charge. This is one of the first, I'm not going to get into history because it's not super important. It's very interesting, but you don't need to know it as far as it's not something I'm going to assess you on. But what I want to mention here is that this is something that's been developed over time. What are these charges? So at some point, you got Thomson, I skipped a few people. You got the plum pudding models, like there's positive charges, negative charges, and then we fast forward to today and the start understanding of the atom, where you got these charges spinning around. All that to say, this took time. These things are really, really small, and it took hundreds of years for people to be able to actually even figure out that they existed. So this field of science of electricity and magnetism took a long time, and there's a reason why electricity, I have no idea when electricity was invented. If you know, you're better than me in that category. But we had to understand these things before we can invent electricity, and now everything's based on electricity, and if it goes out, so good. So many people would die. It'd be awesome. I wanted to say awesome and awesome sarcastically, and then awful seriously, and they combined it, and that's what happened there. So, anyway, all right, so electric charge. It's a property of matter. This is a whole bunch of jargon right now. The property of matter which results in the matter experiencing a force due to electromagnetic fields. That is so much jargon. Sounds terrible. Let's take an easier example of mass. Mass is something affected by gravity. That's kind of like, how would you define that something has mass? You'd say, well, I could touch it. But that's not really a good example, honestly, because there's things that you can feel that you're not touching. We're going to learn when you touch something, you don't touch something. So that's not great. So you kind of, what is mass? It's really, at the end of the day, mass is something that's affected by gravity. That's how it's fun. You got two things of mass, they pull towards each other. Well, this is how the second force comes into play. We have this other thing that's not mass. There's a thing called charge, which does weird things. Instead of being attracted to each other, they can repel. Or they can get attracted way stronger than gravity would account for. So when they were discovering this stuff, they basically found gravity does not explain this. There must be something else. Hey, there's another fundamental force of the universe. It's the electromagnetic force. So things have charge. And these things with charge are affected by this electromagnetic field. What makes an electromagnetic field? Other things with charge. So charges affect charges. Mass affects mass. So we have this new thing called charge. It has the unit of a coulomb, named after a guy with some last name Coulomb. That's the extent I know there. Again, my memory is terrible. So the high school teacher next door, he actually knows all these fun facts. If I learned them, I could promise you next time I taught him, I'd forget them again. That's just how these things go. But feel free to look into it. A lot of units in physics are named after the person that came up with it. So feel free to come up with a unit someday. You can make one up if you want. I can't promise other people will use it. The unit is the coulomb. The variable is lowercase q or capital Q. So this is one of the first things we need to remember in physics is that there is units and variables, and don't get them mixed up. So a unit is what goes after the number. So 3C means 3 coulombs. That means I am talking about charge. If I have an equation, we're going to see later on, I'll just chuck an equation here. Don't worry about this equation right now. You'll see it later. Don't worry about it. All I want to show you is that this Q represents charge. Okay, don't stress about this. We'll talk about this more in detail later. But that Q represents charge. It's a placeholder. It's kind of a short way. I could totally write the whole word charge, but that's a lot of, why would I, it's long. Q, replace it. Why don't we use C for charge? C is used for capacitance. There's only so many letters of the English alphabet. Once they get used, we tend to not reuse them. And there's also probably a historical reason why Q was used as well. Sometimes we're lucky and the variable, the shorthand matches the word, like distance, it's D. Time, it's T. Acceleration, it's A. Other times you get unlucky and there's some history to this where someone called it some other language and it started with a Q and now the shorthand is Q. There's always reasons for these things. I think it's etymology is a study of why words mean what they do. There's a reason why it's a Q. Feel free to look it up. Maybe I'll look it up. Probably not. But it is Q, whether you like it or not. All right, what makes charge? So you all have been told the fact that there's, you cut something in half, you cut it 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 in half. Eventually you get to the smallest unit, which is the atom. And then they said, what if I cut an atom in half? And they're like, oh, but there's protons and electrons. So that's what I'm going to show you. Protons and electrons are the fundamental unit of charge. And I'm going to say these are the smallest unit of charge. I'm saying this in air quotes because guess what? Turns out they're smaller particles than protons and electrons. It just keeps going. They're called quarks. Don't worry about it. For all you care, protons and electrons are the smallest particles that have charge. Again, I told you all physics is always, I don't know if I mentioned this. Sometimes we think we understand something and then there's something smaller or something different. In our case, this is the limit of where we need to go. Proton and an electron are the fundamental units of charge. That's what I'm going to tell you all in class with asterisks, with like a little asterisk next to it. They're actually made of something called quarks, which have 2/3 the charge rate. You don't need to worry about it. All right, protons. Again, this is stuff you've probably seen before. In your chemistry class or if you took high school physics or anything like that. Positive 1.6 times 10 to the minus 19. Very small number, but there's a heck of a lot of these things in the material. Do you remember a mole times 10 to the 23 or 28? Don't remember? I don't know. Great, that's what I was hoping for. All right, there's a lot of them. 23 is bigger than 19. So you can see how this charge gets real big real quick. So 1.6 times 10 to the minus 19 coulombs. That's a proton. Change the sign to a negative. Now you got an electron. If you have one proton, you have a charge of 1.6 times 10 to the minus 19. If you have one electron, you have a charge of negative 1.6 times 10 to the minus 19. The thing that's really important here is if you have an equal number of each, they cancel out. So most things have a neutral charge, meaning equal protons, equal electrons. If I have one proton and one electron, you kind of add these numbers together. That 1.6 times 10 to the minus 19 plus negative 1.6 times 10 to the minus 19, 0. Anything extra will be the net charge an object has. If you have 5 extra protons, 5 times 1.6 times 10 to the minus 19. This is some of the first math we'll be doing in the class, is just figuring out what's the charge of something given the number of protons and electrons. Not because anyone counts the number of protons and electrons in the material, but because it gives us an understanding of how do we get charge. It's literally this. Anything that has charge, it's in discrete units of this number. Bam. Charge is quantized. This is what I was saying. You cannot have a fraction of that 1.6. Any charge will be divisible by 1.6 times 10 to the minus 19. You cannot have, it is impossible to have a charge of 0.8 times 10 to the minus 19. Impossible. Why? Because that would mean you had half an electron, half a proton. Again, I'm saying this with an asterisk. Technically, there's quarks. But for your all's purposes, you cannot have that. We're going to treat protons and electrons as the smallest thing. Meaning, and this weird-looking equation looks way worse than it is. It looks way worse than it is, but it's quite simple. This just says that the charge of something, take how many protons you have, take how many electrons you have, subtract those two, then multiply that by this E. What is E? Well, it's the charge of one of them, 1.6 times 10 to the minus 19. And that'll give you the total charge. So we're going to do an example of this, and it'll show you that this looks worse than it is. It's got, I don't know why it looks worse than it is, but I know it does. Let's pretend that we have 10 and 10. 10 protons, 10 electrons. 10 minus 10 is 0, your net charge is 0. Let's pretend that we had 5 electrons and 4 electrons and 4 protons. 4 protons, I'll write it out because it's going to start to get hard to hold in your head. It's hard to hold in my head already. If I had 4 protons minus 5 electrons, I get negative 1. I have 1 extra electron. And the math gives me a negative 1 because the charge will be negative because electrons are negative. So, things become charged by gaining or losing electrons. That's how it works. Things interact as those things get closer. We'll see that. This is the key fact. Neutral does not mean no charges. I mean, if you just think through the logic there, if something was neutral and I said how many protons does it have and you said 0, that means it has no atoms in it. Because every atom is made of protons. So, everything is made of protons and electrons. At least everything with mass. That's the stuff we're going to be working with. Light, no that doesn't, but that doesn't have charge anyway. And light doesn't have a charge either. So, this is our first clicker question. I don't have the thing set up today because I just talked to you today about it. But try it out. This is an example clicker question. This will take you about 30 to a minute. If I had the clicker system going, I would hit go, and there would be a thing that would count up. As it counts up, I would see your response rates. I would say maybe we have 30 seconds. If I see a lot of people need more time, I'll say, all right, I'm going to give you all 20 more seconds. Time will keep going, yada, yada. If you have the digital version, what will actually happen is when I hit the clicker question, when I hit go, it will send you a screenshot of my screen, of this problem. So that's kind of convenient. If you're at home, that beats the delay. You'll get the clicker question as soon as I hit that button. Also makes it easier for you to answer, all that jazz. So, I'm going to be like, oh, 10 more seconds, all that kind of jazz. Unfortunately, I have no feedback right now because I don't have it hooked up and you aren't responding for how long it's taking. But at some point, I'd go, all right, let me close it. I'd say 5, I'd count down, make sure everyone responds, all that jazz. 3, 2, 1, boom, done. All right, great. So what is the net charge? And then we'll work through the problem. So, we look at our equation last time, the equation that we just wrote down. Q equals number of protons minus number of electrons times that E. We do the math. 7 minus 3. Remember, this middle part is literally just saying, how much extra do I have and of what charge? You can even answer that without doing the math here. If I didn't give you this equation, You would say, I have 7 protons, 3 electrons. What do I have extra of? Protons. I'm not going to insult you. I'm sure you know 7 is bigger than 3. How many more do I have? 4. 7 minus 3 is 4. Look at that. See? So just proving to you all that that's all this is doing. And then it's just multiplying it by the charge of one of those objects. If I had more electrons than protons, as I showed you all, it would have come out negative, which means your final answer would be negative, which makes sense because you have more electrons and they're negative. So this would be 4 times 1.6 times 10 to the minus 19. And 1.6 times that is going to be, now, here's where I told you all, sometimes I'll put the same answer with different units. The answer is this one. C for coulombs. The variable for charge is Q. The unit for charge is coulombs. So again, sometimes I'll do this just to make certain, especially in the beginning, as we're getting back into the rhythm of variables versus units. So there you go. All right, so we got these charges. They exist. Positive and negative. If they don't have a charge, we don't really care about them in this class. All right, insulators and conductors. Insulators, the electrons are trapped to the atom. And a conductor, we have this sea of charges. This is really going to matter more so I'm mentioning it now. This is just kind of foundational stuff. But when electricity comes into play, that's going to matter a lot. We have these free electrons that are free to kind of float around. You can almost think of it like this is a bunch of buckets of water that are sitting around. And this is like a swimming, like I dump all those buckets to get, the buckets are inside a swimming pool. The buckets exist, but all the water is kind of free to move around and all that. The electrons are free to swiggle around and do all that jazz. That's going to matter when we get to some of these polarization stuff, how charges behave. So, how did we understand that this stuff existed? You all have actually probably played around with, you've experienced this. If you've ever taken a balloon and you rubbed it against your head and you moved it away, you'll see, and maybe I'll bring a balloon in next class. I should have brought one today. Oh well. You'll see that that hair sticks to the balloon. This is what the early physicists discovered. The hair was attracted to the balloon. Gravity is probably not explaining that. There must be something new. What must it be? That's the logic of physics. That's how things were discovered. So, if you rub something, some charge can transfer, you bring it through it, you get something called polarization. This is specific to insulators. This is more conceptual. There's not going to be any math here. So this is getting into the discovery of it, and what we're discovering here is that opposite charges attract and same charges repel. That's going to be a mantra that's going to come into play a bunch, especially when we get to the equations and actually describing it. But that's what they discovered here. They took this rod, it had some charge, they brought it near something, and they got attracted to it. You rub your hair on your balloon, you moved it away, the balloon and the hair were attracted. Why? Because of this effect. What's happening here, and again, this can be revisited multiple times, as the positive charge is brought near this box, whether or not this box is an insulator or a conductor, the same effect's going to apply, but we're going to make it a insulator. The electrons are still stuck to the atom, but they can move a little bit. They can move a little bit. So if we have our electron cloud here, this is just a normal electron cloud. There's my positive, and the electrons are floating around. It's a nice spherical shape for the most part. You've probably learned about electron orbitals. There are all sorts of craziness, but we're just going to say they're spherical for the sake of convenience. When this positive gets brought closer, what's going to happen? Opposites attract, like charges repel. That's kind of the mantra when it comes to charges. I have this electron cloud here. It's going to slightly shift closer. It's going to slightly shift closer to the other thing. It can't get pulled away completely, but it can shift. So all the atoms, every single atom, that electron cloud is going to shift. Every single one. And the net result of that is that I get this buildup of negative on this side and this buildup of positive. Not because a bunch of electrons moved all the way across, but just because they slightly shifted. Very, very slightly shifted. So here's a better picture of that electron cloud getting stretched. We call it a dipole. Di meaning two, pole meaning there's a pole. I don't know exactly what pole means. There's a positive and negative. two poles, two different things. You have a negative side and a positive side. Connecting to your chemistry stuff, this is one of the reasons why hydrogen bonds are so strong. Hydrogen bonds are so strong, and I forget the exact which one goes where. You got your hydrogen atoms, you got your oxygen atom. Your oxygen, I believe, wants the electrons. So this side becomes more negative. It actually pulls those electrons, and you get a really strong dipole with water molecules just naturally, and that's why water is so good at breaking things apart, because it will interact with other things and pull them using this really strong set in place dipole. That's just fun fact. I'm not going to quiz you on that or anything. But yeah, dipole, two things, positive and negative. All right, so another clicker question. I have an insulator just like the last time, and I've already kind of shown one of these. So if I bring a positive charge near an insulator, and what's the insulator going to do? Is it going to be attracted to it or repelled by it? If I bring a negative charge near an insulator, will it be attracted to it or repelled by it? And I have every single possible permutation here. I have positives will attract, negative repel, positive attract, negative attract, positive repel, negative repel, positive repel, negative attract. Every permutation is there. Give it a few seconds of thought. What do you think would happen? You can either go with your gut, think through it. You got like 30 seconds. See what you think. You should hope you've seen the answer already for positive charges. So that'll rule it down to at least two choices. All right. So then I close it, ding, 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 whatever. Here's the answer. They would both attract. And that may seem weird because you're like, positive and negatives are opposites. I would think the opposite would happen. We already saw, so let's go ahead and draw the positive example. We already saw the positive example. In fact, I don't even need to draw it. I'll just copy this. My beautiful picture in air quotes. It's hideous, but it'll do. There it is. I'm not going to redraw it for the sake of time. So this resulted in the positive rod. That never didn't change. And this side being negative and this side being positive. Did it already do the thing I told you it would? Let's see. Ready? You get to see it for yourself. See, the writing continues. It's a ghost. I hate it. We have so little time left, I'm not going to restart it. I'll just fix this later. As long as I don't make any mistakes, I'm fine. All right, we are going to learn very soon. Literally, the next thing we cover won't be covered today because we're done in 7 minutes. That if things are closer, just like gravity, the force is stronger. The closer you are to a planet, the more gravity pulls you. The closer charges are together, the more they pull together as well, or repel. So this is going to attract because the negatives are closer than the positives over there. All right, let's look at the negative. What's going to happen here? We have the same situation where we have our atom chilling up here with its normal electron cloud. Electrons are kind of all floating around it, evenly dispersed, living its best life. When that negative gets close, the negative is going to, remember, opposites attract, like charges repel. That mantra is going to be repeated throughout this entire PowerPoint. You're going to hear it like 50 times. These negative charges are going to repel the negative charges. So the negative charges are going to stretch that electron cloud. So the proton will be in the same location, but the electron cloud will get shifted to the right. And every single atom, that electron cloud is going to get shifted to the right. And so we get the following effect. We have a net positive on the left, a net negative on the right. Opposites attract. This positive charge is closer, so these will also attract. Long story short, anytime you all charge stuff, it gets stuck together. When you're doing laundry, the socks get stuck together. When you rub a balloon on your hair gets stuck to the balloon. You take the balloon to the wall, you can make the balloon stick to the wall. It's a fun activity to do with anyone. I do it with my high schoolers, I do it with little kids. It's great. If you take that balloon and you bring it near a stream of water, the stream of water will get attracted to the balloon. You bring it near some piece of paper, it'll get attracted to it. It doesn't really matter what it is, it'll get attracted. So when you have some net charge and you bring it near something that's not charged, that other thing will be attracted to it because of all of this. All right, so this is more conceptual. And why are we spending the time on this? Because this is how they discovered this force. This was the observations that they saw. They had things, maybe a piece of obsidian, I don't remember the exact material, piece of quartz, they had stuff, they rubbed some rabbit fur on it, they brought it near something and it attracted to it, and they're like, that's weird. Other things don't do that. That can't be explained by gravity. I have two other objects and they're not getting pulled towards each other. There must be something else. And that's kind of what led down that rabbit trail of, well, we have mass, but there must be something else, and that's where charge came into play. There must be another force. That must be, that's not due to gravity. It was not because someone told them. They discovered it by observing the universe we live in. That's how physics works. That's how it starts. And then we kind of build through there. All right, so look at that. I hate this. So you totally can't read any of this, but since we got 4 minutes, I'll just quickly say some things real quick, and we'll finish this up next time. Coulomb, again, the guy named after the unit. Look at that. I didn't even need to remember it. It was in my slides. Coulomb was the guy that came up with the law that described this force. That was actually the equation I showed you all before. We'll talk about it next class. KQ1, Q2 over R squared. Look, it even has the date. How great. This probably won't fix eventually. And so he discovered that these charges result in these forces. And by say discovered, he was at least the first person to document it. You know, one of the nature of science is whoever documents it first wins. Someone else may have done it before him, but if they didn't write it down, we'll never know. So if you find out something important but you don't tell anyone, you get no credit. That's how life works. All right, normally I go fully to time, but because my PowerPoint's being funky and because there's usually more questions on the first day, we'll call it good here. Feel free to come on up if you have any question about things, get your clickers, all that jazz. I will upload these PowerPoints, again, this updated one today, so you get to see the process I do for that. So if you want the updated ones by next class, they will be there. 1.9.24 in PDF and Word version, or PowerPoint version.